Drying agriculture products is a difficult job in heavy rainfall areas. Here, the sun will hide behind the clouds for months together, but the farmer is compelled to dry tender areca nut, cardamom, nutmeg and other products despite of persistent rain. Traditional drying system using firewood puts a layer of soot on the product, spoiling its quality. This process consumes lots of firewood also. Further, drying under sun in open yard allows dust sitting on the product. Unseasonal rain is one more problem. To put an end to all these problems, ASTRA division of Indian Institute of Science, Bangalore, has developed a fuel-efficient dryer system. This ASTRA dryer is useful even for home and small-scale industries, producing papad, dry banana, dry jackfruit, etc. He is Mr. M.S. Bhatt, an areca nut grower. Mrs. Sujata Bhatt puts dried unhusked areca nut again in this dryer. It helps for easy dehusking. Unseasonal rain is a major problem here. Hence, they dry tender areca nut, cardamom, pepper, etc. in this dryer itself. This person is Mr. Govind. He uses this dryer to produce dry banana. Mr. G.K. Hegde also produces dry banana and papad with the help of this ASTRA dryer. Dryer technician Mr. Arun Kumar Joshi constructed all these dryers in a systematic design. We find hundreds of such success stories in the Western Ghat regions of Karnataka and Kerala. Fuel-efficient chulha, hot air cum smoke tunnel and drying trays are the main components of this dryer. We have permanent big dryers and portable small dryer models for our choice. We can fabricate dryers of any size depending on the requirement. The wall of this small dryer is fabricated by placing a layer of glass wool between two thick iron sheets. This big dryer is built with hollow tile bricks. Both this glass wool and hollow brick avoids escaping of heat from inside. The chulha at the bottom is a fuel-efficient ASTRA type. Firewood pieces and agriculture waste is used as fuel. This air vent supplies air for proper burning of the fuel. Hot air and smoke pass through this tunnel, releasing heat inside the dryer. But there is no chance of leakage of smoke inside. Smoke goes out through the smoke outlet at the top. The doors have glass wool layer to prevent escaping of heat from inside. This thermometer is fitted to measure the temperature inside. This is the moisture outlet for the escape of moisture generated during drying process. Even the exhaust fan may be fitted to take out excess moisture collected inside when the material spread is too wet. This helps for speeding up of the drying process. Temperature inside the dryer is regulated by increasing or decreasing the fire in the chulha. It is better to construct the dryer under roof to facilitate drying in the rainy season. Now, let us see the arrangement for drying the products. These are the trays with iron frame and wire mesh. It sits on iron angles to make pushing and pulling easy. Product is spread directly on the mesh or on the cotton cloth spread on the mesh. In this big dryer, size of the tray is also big and two trays sit in a step. Weight of the tray is also more when the material is spread. Hence, an independent tray stand is fabricated on small wheels. It enables easy pulling and pushing of the trays along with the stand. Spread of heat is good inside the dryer, but it is not totally uniform. The temperature at the middle tray is 10 to 20 degrees centigrade less compared to the trays at the top and the bottom. Hence, it is necessary to interchange the trays once or twice a day to achieve uniform drying of the product. Different products need different temperature and duration. Hence, it is advised not to put many products at a time for drying. We have to decide suitable temperature and duration by trial and error in first drying. For example, cardamom needs 50 to 60 degrees centigrade temperature for 24 hours. Areca nut needs 70 to 80 degrees centigrade temperature for 24 hours in 2 phases, and coconut needs 55 to 70 degrees centigrade temperature for 26 hours for optimum drying. Maintain required temperature by regulating the fire in the chulha. Closing the smoke outlet after putting off the fire in the chulha will keep the dryer warm for some time. This ASTRA dryer is useful for drying papad, banana, papaya, jackfruit, chili, groundnut, ginger, mushroom, and many more products. We get hygienic and clean output of products. Remove soot deposited in the outlet once in a year. Paint the trays and the dryer body once at the end of the season. Cost of construction of this dryer is around 40,000 to 1,60,000 rupees depending on the size. Many state governments provide subsidy for this dryer up to 50%. This is a modified big dryer constructed by Kadamba Society. This is being used for drying cocoa beans on a large scale. Fans push fresh air in this big metal pipe. Agriculture waste is used as fuel in this chulha. Air passing in this pipe gets heated up by the fire and enters the dryer chamber directly. Continuous circulation of smokeless hot air dries the product spread in the trays. The output will be hygienic and clean dried. This is also a fuel-efficient dryer system. However, this dryer is better suited for small-scale industries.